All right, are you ready for it? We get to factor trigonometric expressions. Sorry, that probably came out as a mumble jumble. We are going to factor trigonometric expressions. So we are going to be looking for greatest common factors. We are going to be factoring difference of squares. We're going to very rarely factor sum or difference of cubes, and we're also going to be factoring trinomials. So here we go. Greatest common factor. What does that mean? Well, it means that however many terms you have, you look to see if they have a factor in common. So with this one, I have a sine squared x plus a sine x cos x. So I can see that these guys, I can take out a sine x because they have it in common. When I'm factoring, you're not dividing by sine x, you're actually factoring it out, right? So it looks like division, but it's not going away, right? It's not like we have this equal to something and we're going to divide both sides by something. We're just taking it out front, and I'm left with sine x plus cos x. Awesome. What about a difference of squares? Well, it has to be a difference of two perfect squares. And when you factor a difference of squares, you draw two brackets, and then you take the square root of the first term and you write it first. And then you take the square root of the second term and you write it second. And then one bracket gets a plus and one bracket gets a minus. Sum or difference of cubes. I feel like I'm going to run out of room here, but a sum or difference of cubes, when you're factoring it, I'm just going to put it below so this fits. You've got your binomial bracket, and then you'll have a trinomial bracket, which I always leave kind of open-ended. To factor a sum or difference of cubes, you take the cubed root of the first term, you take the cubed root of the second term, so the cubed root of 125 is 5. The cubed root of tan cubed is tan. And then if you remember, we send a text message to the second bracket. Now, if you don't know what I'm talking about, don't forget that in your formula sheets at the beginning, we have formulas for how to factor a sum or difference of cubes. So you take the cubed root of the first term, cubed root of the second term, and then you square, multiply, square, and then you put your signs in. Okay, so I'm going to square, and then I'm going to multiply these two together. So I get 5 tan s, and then I square my last term. So 5 squared is 25, and tan s all squared would be tan squared s. Then for my signs, again, this is a difference, so I could go minus plus plus, or you think SOAP. Same sign, opposite sign, always positive sign. All right, the last type of factoring we're going to do is factoring trinomials. So this is when we go squared, no squared, and a 1, or in a constant. I will say, if there's anybody that this is entirely freaking you out, this is why we learned that u substitution thing. I don't know if you remember way back in chapter 3, we would have written this as u squared minus 2u plus 1. We don't use an x because then it reminds us to factor or like substitute back in what we were solving for. But if anybody doesn't like the sign being in there, feel free to do a u substitution where u is sine x and then factor it and put the sine x's back in. Or I'm going to factor these like this. I'm looking for two numbers that multiply to give me 1 and add to give me negative 2. So negative 1 and negative 1. Now you can break up that middle term and do the whole process, or because this is a 1 in front, I know that my brackets would have to have a sine x in front of both. I don't have to have a coefficient. So the two numbers that multiply to give me 1 and add to give me negative 2 were negative 1 and negative 1. So this is the factored version, and I could go even further to write this as sine x minus 1 all squared. This question, I put a couple things into it. So the first thing I hope you notice is that there's a greatest common factor of 2. If you don't, you're going to be looking for two numbers that multiply to give you 24 and add to give you 10, which you can do, but then there'll be a greatest common factor in the end. So I'm going to factor the 2 out to start to be left with 2 sine squared x plus 5 sine x plus 3. And then I'm going to do that with this. So I'm looking for two numbers that multiply to give me 6, positive 6, and add to give me positive 5. So they have to both be positive. So it's going to be positive 3 and positive 2, right? Don't choose positive 6 and negative 1 because that would multiply to give you negative 6. Then some people can do these straight away into the brackets, but you guys were taught that when it's something like this with a number in front that you break up that middle term. So this would be 2 sine squared x plus 3 sine x plus 2 sine x plus 3. And then we factor by grouping. So out of the first group, I can take out a sine x. I'm left with 2 sine x plus 3. Now I already have a 2x sine x plus 3, so I'm going to pull out a 1 to be left with 2 sine x plus 3. And then my final answer will be 2 bracket. I'm going to take out that common factor, and I'm left with sine x plus 1. So this is the final factored version of this guy. Okay, so, and again, sorry, I forgot to mention that if you don't like the signs being in there, write it as 4u squared plus 10u plus 6, and then factor it like that, and then put the sine x back in for u. But let's look at why we're going to use this. So these ones say simplify by factoring. They won't always say that on when we get to trig identities. This is kind of like a leading in of the skills. So for this one, they're telling you they want you to factor. So when I look at this, I've got two terms, and hopefully you can see that there's a greatest common factor. The greatest common factor is sine squared x, and I'd be left with cos squared x plus sine squared x. Now these lessons are cumulative. Once you learn a skill, it sticks. Can I go further? So we've just done the factoring thing, but that didn't really get us anywhere. Except, I now have an addition of two squared trig terms. I have cos squared x plus sine squared x. Woo woo woo! Sine squared x plus cos squared x plus sine squared x equals 1. So I get to replace this whole thing with a 1, and I'm left with just sine squared x. Awesome. Okay. Now I'm like, does anybody think that, oh, look, it's squared. I can now replace it with this 1 minus cos squared x. Well, is that going to make it simpler? No. You're done. And again, look at the back of the book. Am I at the answer? Yes. Okay, I'm done. Am I not? What more can I do? All right, what about this guy? So again, simplify by factoring. So when you look at this one, some people might be tempted to do sine squared x divided by sine x. Don't do it. Please don't do it, right? Order of operations says that you have to do the subtraction before you can do division. So you're not allowed to simplify by dividing if there's a subtraction there. Right? So addition, subtraction, or stop signs. Don't simplify unless this was 1 minus sine x over 1 minus sine x. Go for it, because then they're identical. Instead, what I want you to see is that your numerator is a difference of squares. So my denominator is going to stay as 1 minus sine x, and my numerator, I'm going to draw two brackets, square root of the first term, square root of the last term. One gets a plus, one gets a minus. Now you are allowed to do 1 minus sine x divided by 1 minus sine x is 1. So my final answer would be 1 plus sine x. Whenever you feel like you've got the flow of this, you're allowed to pause the video and try these. But if you're feeling a bit lost, watch me do these, do them with me. And then the more you see them, the easier this will get. So when I look at this one, I see lots of weird stuff, right? My eyes are drawn to these cotan x's, and I'm like, let's change them. But I'm also drawn to this, like, greatest common factor thing. So you get to kind of choose. When you approach a question, you have to think, what can I do? And then you have to decide, what do I want to do first? So this section was called Simplify by Factoring. So let's factor first. We've got a 6 and a 3, so in the top I can take out a 3. We've got cotan x, sine x, and a sine x. So I'm going to take out a sine x. I will be left with 2 cotan x plus 1. Don't forget, anything divided by itself is 1. And then what about the bottom? I have a 9 and a 12, so I can take out a 3. And then again, I can take out a sine x. I'm left with 3 cotan x plus 12 divided by 3, sorry, I got totally lost there, is 4, right? And if it helps you, write the division. I'm dividing by 3 sine x. I'm dividing by 3 sine x. And then what can I simplify? Well, I have a 3 divided by 3, and I have a sine x divided by a sine x. I'm left with just a big giant 1 outside. And then there's so much tempting in here, right? That cotan x you just want to get rid of, but you can't. So my final answer would be 2 cotan x plus 1 over 3 cotan x plus 4. And I can't go any further. I mean, I could change the cotan x into cos x over sine x, but we haven't learned that skill yet for what we call compound or complex fractions. So for this section, you're done. And that should be the answer in the back of the book. Oh, this one I threw in as a challenge. I didn't used to have these in the notes. And then when we got to the trig identities, people were just like, too much, too much, too much. So I've thrown a few in here to throw you some curveballs, but with a lot of support, right? I'm here to do it with you. So the first thing I'm going to look at is the top. This is a trinomial. I'm going to look at two numbers that multiply to give me 6 and add to give me 1. So it's going to be positive 3 and negative 2. Now, I have to do a lot of factoring here, so I really do recommend not doing it within your question. In other words, taking this outside and saying I have 2 sine squared t plus sine t minus 3. I'm going to break that middle term up into 2 sine squared t plus 3 sine t minus 2 sine t minus 3. Oh, I just made it. Then I'm going to factor by grouping. Out of the first group, I can take out a sine t to be left with 2 sine t plus 3. Out of the second group, I want it to be positive 2 sine t plus 3, so I know I'm going to take out a negative 1, plus you always take the sine of the first term. I'm going to take out a minus 1, and I'm left with 2 sine t plus 3. So then I'm going to have that 2 sine t plus 3, and I'm left with sine t minus 1. And that's going to be my numerator. So my numerator, I'm just going to move my equal sign over a bit. My numerator is going to be 2 sine t minus 3, sorry, plus 3, times sine t minus 1. But what is going on with my denominator? My numerator is all in sines, and I've got a 2 sine t plus 3 and a sine t minus 1, and this question said solve by factoring. Well, as soon as you learn something, it applies. So I've thrown a few of these in where it's not just simplifying by factoring. There's something else you have to do as well. I want you to see this Pythagorean identity. And if you're not seeing it yet, that's okay. We still have like 2 more days of lessons where eventually you'll see it. So I'm going to replace the 1 minus cos squared t with what? Well, 1 minus cos squared x, right? If I bring the cos squared x over, is going to equal sine squared x. That's going to make life easier. So I'm going to replace the 1 minus cos squared t with a sine squared t, and then I minus sine t. So now my top is 2 sine t plus 3, sine t minus 1. And then I can greatest common factor my denominator. So I could pull out a sine t, and I'm left with sine t minus 1. This is not easy, right? And I'm, even as I'm making this video, I'm like, oh, did I do too much too fast? But I'm really trying to do more examples so that when we get to the trig identities, you guys aren't just completely lost. So the questions in your homework might not be this hard, but now you've seen it once. So now when you see it again, you'll be like, oh yeah, there's that thing. And I really believe that's what trig identities are. There's a method to them, and the method really is just seeing things. And so the more I show you, the more hopefully you'll start seeing it. So do not panic. If you're just like, no way am I ever doing that, you will. You will, right? You'll see this enough times that you'll be okay. So for this one, my final answer is going to be 2 sine t plus 3 over sine t. And you really just got to put on the brakes. Stop. Nothing more you can do, right? Your numerator has to multiply by 2 and add 3 before you can divide by sine t. So you're not allowed to take out a sine t, right? So many people are tempted. They're like, the answer is 5. No, it's really not. So that is the end of this video.